Okay, so we're going to talk about parallel lines today, 5-6, the first part of 5-6, parallel lines. Your learning target, you can identify, graph, and write equations of parallel and perpendicular lines. Today, all you're going to be able to do is identify parallel lines. That's my learning target for you today.
Love this.
Okay.
This is fun.
Okay, so parallel lines. We just talked about it. Parallel lines look like this, like a railroad track or road. Looks like that, like this, anything. They're lines that never intersect. The reason they never intersect, the purpose behind that, is because they are rising or decreasing at the same rate. This is huge. Because now this is aligning us with our 8th grade standard of linear equations. If I say that they are rising at the same rate, rising or decreasing, that is really slope. Rate is slope, right? If I had a coordinate plane, and I had this line, kind of a steep slope, well then a line parallel to it better have a steep slope, right? So what we have here for parallel lines is all related to the slope. If they rise or decrease at the same rate, they're going to be parallel because they keep increasing equally and they will never ever intersect. On your line, I want you to, or on this little coordinate plane, I want you to graph these two lines and identify if they're equal or parallel, okay? Remember, this is slope-intercept, so this is the y-intercept, and the slope is really 1 over 1. So I'm going to graph this. I have a y-intercept at -1, slope up 1 over 1, up 1 over 1, or down 1, other way 1. There's that line. And you have to know how to graph from slope-intercept. Anytime y is by itself, you should be able to recognize where it should cross the y-axis and what the rate is, what the slope is. The next line, y equals x plus 2. This is the y-int. The slope is 1 over 1. So I graph the y-intercept first. That's at 2. And then my slope is 1. So I go up 1, over 1, up 1, over 1, down 1, other way 1. Are these lines parallel?
Yes.
These lines are parallel, and if you notice, the m, the slope of this one is 1. So slope 1, I'll call it slope 1. Slope 2 is also 1. That's saying that that's satisfying that they increase at the same rate. If they increase at the same rate, it means they have the same slope. If they have the same slope, they are parallel. Same slope, parallel. Same slope, parallel. So, like I said, my learning target for you today is to identify if you have parallel lines. The only way you can identify without actually graphing is you always want to be able to check the slope. That's our target. Check and compare slope. If the slopes are the same, they are parallel. So the first thing we want to do is make sure it's in y equals mx plus b form. That means y alone. You want to be, this is where we have to be confident with getting y by itself. Adding and subtracting that x term, and then dividing by that coefficient of y. You have to be masters at that. Parallel lines have the same slope. They have different y-intercepts. If they had the same y-intercept, they'd be the same line. I'll give you a visual here. The blue line is parallel to the green line. So they have the same slope. But if I make a red line, notice they have different y-intercepts. If I make a red line with the same y-intercept, it's just the same line. So that's why in order to be parallel, they have to be at different spots. Otherwise, they're just the same line. Okay? We're going to identify which lines are parallel. Okay? So here I'm looking, I have a slope of 3. So to be parallel to this line, I must find another line that has a slope of 3. Do you see another line that has a slope of 3? Which one? Say the line. Yep. And now the negative 3x, that wouldn't be it. Imagine if we drew, I always draw a rough coordinate plane. If I had 3x minus 2, I'd look like this. 3x plus 2, I'd look like this. Oh, that looks like it's going to intersect. They're parallel. If I had the negative, negative goes down. So negative 3x plus 4, they're going to intersect because that's going down. So they have to be the same sign. Okay? So parallel, y equals 3x minus 2, and y equals 3x plus 2. They are a set of parallel lines. Again, to identify parallel lines, we are looking at the slope. The next slope, that's all I'm looking at, slope. 2/3. Do I have another 2/3?
Yeah.
Yep. So y equals 2/3 x plus 1. And this one has 2/3. Y equals 2/3 x minus 1. And while you're just getting started with this, you might want to box off the slope because that is our main thing with parallel lines. We are focused on our slope. That's our main goal. We want to know the slope. That's why we want y alone, because y alone tells us slope. Okay, did it? Did it? 4, is there another 4? Is there, so if there's not another 4, is there another line parallel to this on here? No, you have to have the same slope. Negative 3, is there another negative 3? No, so there's no other line parallel to it. Negative 2/3, is there another negative 2/3? Nope. Done. So there were 2 sets of parallel lines. Okay, so we're going to now bump it up. To identify parallel lines, you need to first get them in slope-intercept form. That means this. The reason why we need it like that, y alone, is because this m tells us the slope. Now I'm going to tell you a lot of 8th graders do at first. If I say, what's the slope of this line? A lot of kids are going to think 3, right? The 3's in front of the x. Sure, it's 3. I'm going to show you that that is not the slope. We need y by itself. So this is where we use the strategy, get rid of the x term. Because I really have 2 lines here. Get rid of the x term. 2y equals negative 3x plus 4. And then divide by the coefficient of y. Y equals negative 3/2 x plus 2. My real slope is negative 3/2. It is not 3. Do you see? So you have to have y alone before you identify slope. Say it. Have to have y alone before identifying slope. Say it. Have to have y alone before you identify slope. Hey, my slope is alone here. 2/3. Negative 3/2. Are they parallel? Are they the same?
Yeah.
Not parallel. They are not the same slope. Again, that's our goal. We want the same slope. Notice my strategy of boxing off the slope. That keeps my brain activated that all I care about is slope. I'm comparing the slope. Okay, next lines. 3y minus 2x equals 4, and 2x plus 3y is 1. I want to know, are they parallel? I can't compare them right now. I need to get y alone first. So I'm going to add 2x. I have 3y equals 2x plus 4. Remember, it's not 6x. They're not like terms. And then divide by 3. Y equals 2/3 x plus 4/3. It's okay to have 4/3. Again, I don't care about that. All I care about is the slope. That's the only thing I'm going to be comparing. Now I got to do the next one. So a minus 2x. I get 3y equals negative 2x minus 1. Divide by 3, divide by 3, divide by 3. Y equals negative 2/3 x minus 1/3. It's ugly, sure looks ugly, but again, all I care about is the slope. Is 2/3 the same as negative 2/3? So not parallel.